Okay, so in this one, we're going to go through our final part of this question, part C, where we're going to use E equals mc squared to calculate the energy equivalent of this mass difference in joules and mega electron volts. Okay, so just remember in our last example, we worked out the mass difference between the fission, so the splitting up of uranium-236 and lanthanum-148 and bromine-85, as well as 3 neutrons, as 2.85762 by 10 to the negative 28 kilograms. So in theory, the mass should always be equal to one another, but this isn't the case, okay? So this mass has actually disappeared in the form of energy, and this is where Einstein's equation E equals mc squared comes into use here. So with this, we have our mass, okay, that we worked out. So our mass difference, okay, that's what you want to use for E equals mc squared, because that's the energy that's being formed from this mass that's disappeared, okay? So we've got our mass there. C is speed of light, okay? Ooh. And that's summarized down the bottom here, okay? And we've also got down the bottom what 1 mega electron volt equals in joules, okay? So they're pretty much everything you need to do, and it's just plugging in numbers into our equations. So first, our energy is equal to mc squared. Okay, so just remember this one's got to be in joules, okay, when you first work it out. So our mass, that's in kilograms, so that's all good. So we just need to fill in these values, is equal to 2.85762 by 10 to the negative 28. Okay, and we just need to multiply this by c squared, which is 2.9. Oh, and I'm going to run out of room here. I'm just going to zoom out. Which is equal to 2.99792458. And you can abbreviate this to 3, okay, as well. So, and often it is, okay? So this here is by 10 to the 8, and all of this is squared, okay? So you work this out in your calculator. Good luck if you can do it in your head, okay? So with this, we've got 2.5 68301, and this is in joules, okay? Sorry, by 10 to the negative 11, and this is in joules. So this is the value that you will get in joules, okay? So we've ticked off, we've worked it out in joules, but it's also asked us to work in mega electron volts. So we've got our conversion rate down here, okay? 1 mega electron volt is equal to 1.602176 by 10 to the negative 13 joules. Okay, so to work it out in mega electron volts, we just need to get our value that we got there and divide it by 1.602176 by 10 to the negative 13. So this is equal to 2.5. 301. Don't forget you buy your 10 to the negative 11, and we need to divide this by 1.602176 by 10 to the negative 13. Okay, so with this now, this should come out to a value of around 160.300789 mega electron volts. Okay, And then just remember at the end, state the solution. So you could write something like the energy equivalent of this mass, because that's what's happening there. And this is how we explain where this mass has gone. This mass difference, and just state your answers there. I'm not going to write them out again, so state this answer here or this answer here or both, okay, as it does say joules and mega electron volts, so better to do both. So I'm just going to go over this whole question again. So just remember, break it down into parts. It is a very long question, but it doesn't really take too much. A lot of it's just adding and subtracting and then putting into E equals mc squared at the end. So just remember, first break down, write out your equation or your fission equation. That's always the best way to start, okay, that I started off in part A. And then just slowly work out your differences. So your differences in your binding energy, okay, so that showed that there's going to be some energy difference, and then difference in the sum of the masses, and then work out your value at the end. So with this, hopefully you realize that your values for this one from our first one and our second one, these differences are very similar, and that's a good indication there, okay, that these are very similar. So part A to part C. So this is a good indication that these, or that this theoretically works out and you've done all the right things. Okay, so hopefully this helps with these types of questions, and good luck.